Hi, in this video, we're going to be talking about the space complexity of algorithms. Space complexity is the measurement of total space required by an algorithm to execute. In computer science, there are multiple ways to solve a problem, but to pick an efficient one of the things we must consider is how much space our algorithms are using. The space complexity of an algorithm can be thought of as the auxiliary space used by the algorithm, which is the extra space or temporary space used by the algorithm, plus the memory used by the algorithm's input variables. Let's take a look at some tables that will help us determine the space complexity of an algorithm. Most things that you do when programming require the use of computer memory. This table shows us the memory cost of some data types that you've seen in Java. We can see that an int, for example, costs about 4 bytes of memory. Anytime you initialize a variable as any of these data types, you are using some amount of memory. It's important to remember that different programming languages may have different sizes for their data types. This table here is specific for Java, but also similar to many other languages. You can also use big O notation when describing the space complexity of an algorithm. If an algorithm takes up O of 1, or constant space, it means that the algorithm takes up the same amount of space regardless of the size of the input that we give it. If an algorithm takes up O of n, it is using linear space. An O of n algorithm will take up space that is proportional to its input size. Let's now take a look at two algorithms with different space complexity. The first example is of a method that sums two integers. The first int argument, a, requires 4 bytes of memory. The second int argument, b, will also require 4 bytes of memory. Finally, the return statement, which is also an int, like a and b, takes up 4 bytes as well. So in total, this algorithm uses 12 bytes of memory, and so its space complexity is O of 1, or constant space. Now let's take a look at an algorithm that takes in an array as an input and then sums up the elements that are stored inside of that array. Since the array we are using is getting passed in as an argument, it could have any number of integers. Since we know that an integer needs 4 bytes, the array itself will require 4 times n bytes of storage. Next, we have the int variable size, which also requires 4 bytes of storage. The variable sum also requires 4 bytes of storage. And lastly, the int variable I will require 4 bytes of storage as well. So in total, we have 4n plus 12 total bytes being used by this algorithm. In big O notation, we can say that this algorithm is O of n. By analyzing the amount of time an algorithm takes to run and the amount of space it takes up, you are able to make your algorithms more efficient. We know that algorithms should be fast, and they should take the least amount of memory as possible. Unfortunately, oftentimes space and time work against each other. Increasing speed will most often lead to increased memory consumption, and vice versa. Later in this course, you'll come across the merge sort algorithm, which uses a lot of space but is an extremely fast algorithm when used in certain situations. And then you will also be introduced to bubble sort, which is a pretty slow algorithm, but it requires very little space. Now it's time for you to explore these concepts further. Have fun!